So today we're going to look at adding and subtracting fractions, and some of these are going to be positive and negative numbers, like you'll see here. So I have a negative 1/3 plus a negative 3/5. All right, so adding is combining things, right? Counting things up. And when we have fractions, whenever we're adding or subtracting, you must get a common denominator. That is the must with adding and subtracting fractions. You have to have a common denominator because that common denominator means equal size parts. So right now I have thirds and fifths. Those pieces are not going to be the same size. Those parts are not going to be the same size. Thirds are bigger than fifths are. It just means I have one whole cut into, it's not perfect, but into 3 parts versus one whole that would be cut into 5 parts. So you can see these are bigger, larger than these ones are. So I want to get them to where they're the same size pieces. So I look at the denominators and I try and figure out what common multiple they have. What can 3 go into that 5 can also go into? And one way to do it is to multiply these two together. It's not always going to be the smallest, but it will always work. 3 times 5 is going to get me to 15. So I want to change 1/3 into 15ths and 3/5 into 15ths. And this is a negative 3/5 and this is a negative 1/3. So I'm going to get a negative and a negative. Well, to get from 3 to 15, that's times 5. So I have to do 1 times 5 to get me 5. So negative 1/3 is the same as negative 5/15. To get from 5 to there, that's times 3. Negative 3 times 3 is a negative 9. Okay, so now since I have them both as 15ths, I can solve the problem out. It's negative 5/15 plus a negative 9/15 here. My denominator is just the size of the pieces. It's how many it would take to make up one whole, so that's not going to change. And a negative plus a negative is going to stay negative. So 5 and 9 is going to make 14. So my answer is negative 14/15. I just changed the size of the pieces, but the values are the same. You can see from what we did before, these are equal to each other, so I'm able to substitute them in without changing the problem. All right, another one. If I had maybe a negative 7/8 minus a negative 2/3. Okay, in this case, first thing that I notice, it is what we learned about with our adding and subtracting integers. If I'm taking away a negative, I'm taking out the bad guys, that means we're adding. So this problem would be a negative 7/8 plus 2/3. Well, with 8 and 3, my common denominator could be 24. First one's negative. You can't forget about the signs. You can't lose track of the signs. 8 times 3 makes 24. 7 times 3 makes 21. So these two are equivalent to each other. Plus, it was thirds. So 3 times 8 gets me to 24. 2 times 8 would make 16. Now I have a negative 21 and a positive 16/24. So in order to do this, one is negative, one is positive. You have to subtract those numbers. 21 minus 16 is 5. So 24 is there, and 5 is the top number. There's 21 parts that are negative and only 16 parts that are positive, so I have more negative parts, so my answer is a negative 5/24. We'll do one last example. let's say I had 5/6 plus a negative, I don't know, let's go 3/8. So again, we have a positive and a negative, meaning we're ultimately going to subtract. With 6 and 8, a common denominator could be 24. And you know how I figured that out? 6, 12, 18, 24. 8, 16, 24. They both go into 24, so I know that could be my common denominator. 6 times 1, 2, 3, 4 is 24. So 5 times 4 is going to make 20. Again, multiply them by the same thing. It was times 4. So 5 times 4 is going to make 20. 8 times 1, 2, 3. So 3 times 3 is going to make 9. I have a positive number and a negative number. There's more positives than there are of the negatives, so my answer has to be a positive. 20 minus 9 is 11, and 24th is what it stays as. There will be times when you'll come across an answer. Hypothetically, we get an answer of something like, we'll just say 18 over 54. Okay, if we had an answer like this, then I would want to simplify. And in order to do that, I would say what can go into both of these? Well, I could divide by 2, or if I picked a larger number, I could divide by 9, because 9 goes into both. 18 divided by 9 is 2. 54 divided by 9 would be 6. And wouldn't you know it, I didn't pick the biggest number either. It looks like 18 would have went into both. 18, 36, 50, yeah, 54. So that would be 1/3. And just kind of showing you here, I could have done it better if I would have divided them both by 18. 18 divided by 18 would be 1. 18, 36, 54 means 3. So it does equal 1/3, whether I take a couple steps to get there or just one step. But if you can simplify, it's a good thing. These are all equivalent to each other. They're all right answers, but this one's a little bit easier to understand, to work with, since we have the numbers are smaller there.